know. Sometimes you might read it and not necessarily even know that this is important stuff, or you might be focusing too much on something that isn't important whatsoever. So I'm going to go ahead and share my screen here so you guys can see it. And I'm going to go through this together with you. Cast desktop. Okay, so if you want to follow along on your own computer, that'd be great. It looks like it's only going to take around 45 minutes. So it's not going to take the entire class period, which allows you time to do what you need to outside of this. Okay, so first I'm going to pray for us. After I pray, we'll get started. Dear Heavenly Father, we thank you for this time that we have together. Lord, I pray that we're just able to continue to learn new things, to be focused, and that we're able to tune in here for the next 45 minutes to get this done, to just continue to seek to glorify you with our actions. I pray that we give our full 100% effort to everything that we do, that we don't do things in halves, and we focus on the importance of your influence in our lives. We are grateful for this time we have today and know that you are our ultimate problem solver. In Jesus' name, amen. All right. So starting something new, I guess 1.5 is a continuation of 1.4 and 1.3. We are in, so this is 1.5 compound assignment operators. It says it should take around 45 minutes, but it may take less. Along the way, if you have questions as I go through this, let me know. It's also good to be following along on your own, so that way you can be able to complete yours in real time. It says compound assignment operators are shortcuts that do a math operation and assignment in one step. I like shortcuts. It's always good to learn the long way. Like as a math teacher too, I always show you the long way of doing things and then show you the shortcut so you appreciate the shortcut a little bit more, right? Whatever's the easiest possible and most time efficient way. Now, with that being said, sometimes, as I mentioned, it's better to learn the long way first, so that way you're able to appreciate this a little bit more. So we already learned the long way, but it says, for example, x plus equals 1 adds 1 to x and then assigns the sum to x. It's the same as, and look at this, it says x equals x plus 1. Okay, it's the same thing. So rather than taking the score and saying score is assigned the value of score plus 1, instead of writing that score twice, or in this example, instead of writing x twice, you can just write it once and say, all right, x plus 1 equals whatever the x is, so whatever your value was. So let's say x is 9. And you have x plus equals 1. X now has the value of 10. Okay. So below there's a chart, which I'll get to in a second. It says this pattern is possible with any operator put in front of the equal sign as seen below. So we learned the mathematical operators last week. We used plus, we used minus, we use multiplication, which is the asterisk. And then we have the forward slash, which is division, and then the percent symbol, which is modulo, which is a remainder. Okay, so I have my shortcuts. X equals x plus 1 is now x plus equals 1. All right, that's a shortcut. You can write either one. And then even in Java, Java offers an even shorter shortcut and just says x plus plus, and that adds 1 to it. There's a programming language called C. And then when they created like a new programming language that used a lot of C's capabilities, but wanted to add a bunch of stuff to it, they called that language C++, which really it's just C plus 1, right? So it's like whatever that C language was, let's add on to it. And there's also a language called C#. And if some of you guys are familiar with music theory and playing an instrument, there are different notes you can play, different chords you can play. And there's a C chord, and then there's also a C#, which is moved up one. So one level above is C#. It's a programming language. So that's where C++ comes from. You're adding one. If you're looking at the subtraction shortcuts, you could have written x equals x minus 1. Let's say you want to subtract 1 from a number. Let's say lives, right? You're creating a video game, and you're saying lives equals, the new lives is equal to, assign the value of whatever the lives was, minus 1. So let's say you start off with 5 lives in your video game, and you ended up falling down a mountain, right? And you reset, the game resets, and you only have 4 lives. The way you know that is you have your lives minus 1, and then it assigns that to lives now. Okay. A simple shortcut, x minus equals 1 or x minus minus. And notice that the other 3, multiplication, division, as well as using the modulo symbol, the remainder, these don't have these third additional shortcuts, right? Multiplication, very similar. You're really just taking the mathematical operator and putting it in front of the equal sign. And if you feel more comfortable without using the shortcut, then do that. Okay? It's like when you're writing what is in the English language. If you're writing out what is, you can shorten that by saying what's. Or instead of saying that is, you can say that's. Instead of saying let us, you can say let's. Right? No one says let us go. Right? Let's go. So there are shortcuts and ways you can make it easier, right? But you don't have to use them. We're learning them. They may ask you to use the shortcut here in this lesson since we're learning it, but the purpose of this is to make it easier when writing code, or to recognize that other people are going to write code maybe in a little bit different way. The most common shortcut operator, plus or increment operator, is used to add 1 to the current value. So x is the same as x plus equals 1. I already said this, right? It is a shortcut that is used a lot in loops. Okay, we'll talk about loops later on. Don't worry about loops right now. If you've heard of the programming language C++, the plus is an inside joke that C has been incremented or improved to create C++. The double minus decrement operator is used to subtract 1 from the current value. We've already talked about this. These are the only 2 double operators. So you can't like say x multiplication symbol, x asterisk, asterisk. You can't do that. This shortcut pattern does not exist with other operators. Run the following code to see these shortcut operators in action. Okay, so it says run the code below to see what the double plus and shortcut, they spelled it wrong, typo, and shortcut operators do. Click on the show code lens. All right, so let's just run it. Okay, it says try creating more compound assignment statements with shortcut operators and work with a partner. All right, so we'll look at this. Okay. So really, we're starting off. Here's my main method. Let me walk through this. I've created a variable called score. Say you're creating a game. It's an integer. That's my data type. And I'm assigning it 0. And then I'm printing out the score. And the score should print out 0. But then if I add 1 to it, score plus, that should add 1. If you look down here, right? This area in the gray, it first printed out 0 and then printed out 1. Then for some reason, we took the score, multiplied it by 2 and assigned it back to score. And take a look at this real quick. I'm going to zoom in here, right? So you have score. Think of score times 2 equals the new score. So that's the way I see it, like whatever's close. So score times 2 is now assigned back to score. Okay. And our value was 1. So that means score, when it's printed out right here in line 10, you see in line 10, it's printed back out, it should be 2. And then we went ahead and signed an integer, right? We assigned it penalty. I'm guessing maybe you ran into something that you shouldn't have in your game. And every single time you run into it, you want the user to subtract 5. So say score, and the penalty has been initialized, right? 5 divided by 2. We're going to do that first. Since score is an integer and it's stored as an integer, 5 divided by 2 is 2.5. But an integer version of it will only pick up the whole value, right? It'll only pick up 2. So now, since 5 divided by 2 is really 2.5, an integer value is 2. So the score was 2. We're subtracting 2 and then assigning it back to the score. So the score now, when you print it out, is 0. Last week, we talked about integers and doubles. Doubles were the other type of numerical data type that we talked about. And doubles allow you to store decimals. Since our score, if you look at the very top here, score was declared as an integer, I can't have a decimal. So although penalty divided by 2, 5 divided by 2, even though it's 2.5, it can only store the 2. All right. So that is the code that it wanted us to run. It says I passed it, and I will move on. There's a little note here. And it says, on the AP exam, you can use X++ or ++X to add 1 to the value of X. These two shortcuts only have different results if you assign the value of X to another variable, as in int Y equals ++X. Okay. Now, if you look at this, the ++X, you have to be careful because that will assign the value before actually doing any sort of mathematical operation to it. Okay, so it says where the value of X is incremented just means you're adding to it before Y is set to it. Okay, so where Y is a copy of the X's value before the X is incremented. The AP exam will never use a shortcut in an assignment statement, so you don't need to worry about the difference. So that's kind of weird. They introduced this and said, hey, look, like on the exam, you can use this, but we're not going to use it. Okay, it says 152. What are the values of X, Y, and Z after the code executes? Okay, so if we're walking through this step by step, right, I'll zoom in. It says X is equal to 0. Y is assigned the value of 1, and Z is assigned the value of 2. X minus minus, that means we've subtracted 1 from whatever the X value was. And X was 0, so 0 minus 1 is -1. So I know that X is -1. So it has to be either A, B, C, or E. Let's continue with Y. Y plus plus, we had Y as assigned the value of 1. So 1 plus 1 is 2. Okay, so now we know that it must be B, C, or D. Sorry, B, C, or E. Then we have Z is assigned the value of 2. Z plus equals Y. So we're going to take whatever Z was, and Z was 2. And we're going to add whatever Y was, and Y we've assigned 2. It's now 2 because we added 1 to it. It was 1. So now we have 2. So 2 plus 2 is assigned back to Z. So 2 plus 2 is 4. So Z should be 4. Okay. So we had -1, 2, and 4. So the answer should be E. Y is equal to X equal to -1, Y is equal to 2, and Z is equal to 4. Let's see if we're right. Maybe I got something wrong. Nope. It says, looks like we got it right. All right. The next one, 153. It says, what are the values of X, Y, and Z after the following code executes? Okay. So these are like little puzzles, right? When I was getting my Java certification, you go to school, you study, you take your classes, whatever. Then you take your Java certification if you want to be a Java programmer. And a lot of questions like this were on the introductory exam. I'll give you little problems like this. X is assigned the value of 3, Y is assigned the value of 5, Z is assigned the value of 2. Cool. They're all integers. All right. X is assigned the value of Z times 2. Okay. So that means X, and I'm probably going to have my pencil with me. No, I don't. Oh, well, I was going to write these down so I don't forget them. So Z times 2, which is really 2 times 2. So 2 times 2 is 4. 4 is assigned back to X. Okay, so I know my answers must be B, D, or E because those show me X is equal to 4. Y is assigned the value of Y divided by 2. So 5 divided by 2 is 2.5. But like I mentioned before, we're looking at the integer and it's not a double. So instead of 2.5, the 0.5 will be taken away and Y is equal to 2. Okay, so that means that the answer has to be E. But let's go ahead and just do the last part just to finish it off. Z plus plus, Z was 2. You add 1 to 2 and you get 3. Right? So the answer X equals 4, Y equals 2, Z equals 3. Let's check it. And it looks like it's right. All right. Next up, 1.5.1. It says code tracing challenge, an operator's maze. Use pencil and paper. So this does require me grabbing a pencil. I'll have to write this out. Use pencil and paper or the question response area below to trace through the following program to determine the values of the variables at the end. So I don't know what that means yet. I'll have to look at it. Code tracing, it's a vocab word. Code tracing is a technique used to simulate a dry run through the code or pseudocode line by line by hand as if you are the computer executing the code. A dry run means that it's not the real actual running of the code, but it's you practicing. It's like you have formulated a plan. Like, I mean, if you're creating a robot, for example, I'm thinking of a robotics team, and you want this robot to follow a specific pattern to go through a maze. A dry run would be you sitting down and writing out exactly where you want it to go throughout the maze, right? It's kind of a test. It's not the actual execution. Okay. Tracing can be used for debugging, finding out what's wrong with your code, or proving that your program runs correctly, or for figuring out what the code actually does. Okay. So there are these things called trace tables. Trace tables can be used to track the values of variables as they change throughout a program. To trace through code, write down a variable in each column or row in a table and keep track of its value throughout the program. Some trace tables also keep track of the output and the line number you're currently tracing. So it's just saying, look, like, let's make sure this actually runs. Sometimes you just want to run your code and see what's wrong with it. But if you have time to go through and look through your code and make sure before you run it that it looks good, that's always a good standard. So that way we're not getting a ton of errors in our code every single time we run it. Okay. So it's showing different examples of trace tables. This one and this one. It says trace through the following code, the same as what we've been doing. I've been verbalizing it out loud, but it's saying get a piece of paper. And it's funny, before I even got to this part in here, I was already thinking about, I mentioned I might need a pencil to trace through this. So it says X assign the value of 0. y is assigned the value of 5, and z is assigned the value of 1. Okay, so let's see what I got it. Okay, so it says, here's what I'll do. I'll do x is equal to y is equal to z is equal to. And these aren't going to be the final answers, just as I trace through. So starting off, after reading the first 3 lines of code, x is equal to 0, y is equal to 5, and z is equal to 1. All right. So now it says x plus plus, this line of code. All right. So x has been added 1. So I'm going to go ahead and add 1 to it. Then it says y, subtract 3 from it. This line of code right here says y minus 3. So I'll find my y and I'll subtract 3 from it. Then it says z is assigned the value of x plus z. So x assigned the value, sorry, z is assigned the value of 1 plus 1. I'll make this a little bigger if you want. Right? So z is assigned the value of x plus 1. That's 1 plus 1. That should give me 2. All right. Let's go to this line right here. X is now, see how we're changing the variable's values? That's very common throughout a program. Something might have happened and we need to change the value. So x is assigned the value now of y times z. Y times z, 2 times 2 is 4. So x, completely forget that it was equal to 1 because now it's 4. Right? Y is, and this is divided by 2, whatever the remainder is. So if you take whatever y is, y divided by 2, 2 divided by 2 is equal to 0. Sorry, is equal to 1. 2 divided by 2 is equal to 1. The remainder is 0. There's no remainder. There's nothing left over. So I'm going to go ahead and assign this the value of 0. And then the last line, it says z minus minus. So z was 2. I'm going to subtract 1 from it. And what I did was I traced through this code. Now, something that you might not have tracked and might not have understood was this last line, right? Or sorry, the second to last line. This symbol, remember, this percentage sign, it divides the number and returns the remainder of whatever's left over. So like 5 divided by 2 is really 2.5. The remainder would be 1. Okay, so 5 divided by 2 is 2 point. And if we're just looking at that, what's left over? 1 is left over. So that's how we got that number right there. All right. So that's what I got. I'm going to go ahead and save it. It says my answer has been saved. If you guys got something different, let me know. That's what I got. It says, after doing this challenge, play the operator's maze game. Let's see what that is. Okay. Oh, yeah. That's a lot. You don't have to do that. That's just a recommendation. You don't have to do this. You got a different answer? On this one right here? All right, so let me trace back through it. So that's what we originally got. X is equal to 4, 0, 1. Let me just put that 4, 0, and 1. So let's go back and reset. Okay, gotcha. Gotcha. All right. So that should be what you get. If I sometimes I don't know, I make mistakes, but all right. So this is basically like you starting here and then taking X and performing all these operations to it. And then what do you finally get at the end? I'm not going to put you through that. You don't have to do that. But if you want to practice is a good thing. Okay. See if you and your partner get the highest score. What would be the highest score? When you've completed your journey, compare your results to other grades class. What is the highest possible X value? Okay. All right, just a summary. Didn't go through a lot today, but we were able to complete this. It says compound assignment operators, plus equals, minus equals, multiplication equals, division equals, and then the modulo equals can be used in place of the assignment operator. The increment operator, the double plus, as well as the decrement operator, the double minus. You notice how when you type double minus, it kind of just made like a hyphen or a bigger. Really, that's a double minus. That should be more clear for you. They're used to add one or subtract one from the stored value of a variable. The new value is assigned to the variable. Okay, so the use of increment and decrement operators in prefix form, plus plus, and inside the other expression, we don't have to worry about this yet. These are arrays. We haven't gotten to them. Don't worry about that. Don't let that confuse you. Is outside the scope of this course. And that's exactly what it says. That's what I was saying. I was like, why are they even talking about this? That's completely outside the scope of this class. And then it says that. So I should have just read through the rest of the sentence. All right. So it says I've completed 5 out of 5 activities on this page. Completed. Well done. That's what you should see at the bottom of your page. All right. If you want to go through and do this maze game, you can. All right. So I believe we did this under 45 minutes, but we were able to complete this. And that is 1.5 compound assignment operators.